Hi everyone! Today we'll be talking about quadratic functions written in standard form. So given a quadratic function in standard form, I will be able to label the different parts and match the function to its graph. Here are some examples of graphs of quadratic functions. Remember, a quadratic function has a highest degree of 2. And notice here, the graphs are curves or parabolas. What are quadratic functions written in standard form? Let's take a look. A quadratic function written in standard form looks like this. F of x equals ax squared plus bx plus c. So we have the highest degree 2, which makes it a quadratic function. Notice we have 3 parts, and we have the a, b, and c. These a, b, and c values are going to be numbers. We just don't know what they are yet. It depends on the function. So again, a, b, and c are unknown values. For our first example, we're asked to label or identify a, b, and c when we're given the quadratic function f of x equals 2x squared plus 4x plus 6. So we have to find a, b, and c. The standard form of a quadratic function is f of x equals ax squared plus bx plus c. What numbers are replacing a, b, and c? So for a, notice that it's a 2. For b, we have 4. And for c, we have the constant 6. So we have found a, b, and c. So a equals 2, b equals 4, and c equals 6. We're simply finding a, b, and c. And you don't have to write this in your notebook, but this is what the function would look like as a graph. In this next example, I have f of x equals 7x squared plus 9x plus 5. For a, we have 7. For b, we have 9. And for c, we have the constant 5. So we have a equals 7, b equals 9, and c equals 5. A is the coefficient of the quadratic term, b is the coefficient of the linear term, and c is simply the constant. For this example, our graph looks something like this. Please try this example on Edpuzzle. Label a, b, and c when f of x equals 6x squared plus 2x plus 6. For our fourth example, we have g of x equals negative 3x squared plus 9x minus 5. Let's identify a, b, and c. So a is the coefficient of the quadratic term. So notice here it's negative 3. b is the coefficient of the linear term, so it's positive 9, and c is the constant, negative 5. So here we have a equals negative 3, b equals positive 9, and c equals negative 5. Be careful whenever you see negatives. The graph of this function looks like this. On Edpuzzle, please identify a, b, and c for g of x equals negative 8x squared minus 6x plus 4. For example 6, we're going to identify a, b, and c for h of x equals x squared plus 4x minus 7. It's pretty easy to identify b, which is 4, and c, which is negative 7. But what about a? Because it looks like there's nothing right here. Remember, right here, it's like there's an invisible 1. Because x squared and 1x squared are the same thing. We just don't write the 1 usually. So we know that a equals 1, b equals 4, and c equals negative 7. So just be careful about the invisible 1, but the rest is similar to your previous examples. And this is the graph of our h of x function. On Edpuzzle, please label a, b, and c for h of x equals x squared plus x minus 9. For our next example, we have k of x equals 2x squared plus 3x. We know that a equals 2 and b equals 3. But what about c? Notice there's this empty spot where the constant usually would be. So we use a 0 because 0 symbolizes emptiness. So we have a equals 2, b equals 3, and c equals 0. Again, we know that c equals 0 because it was an empty space. And this is the graph of the function k of x. For this example, I have k of x equals 8x squared minus 5. Notice that I am missing something here. So a is 8, and I also see that c equals negative 5. But what about b? Notice that I'm missing a linear term. Right here, usually there's a linear term, but since it's empty, I'm going to use plus 0x. So b equals 0. A equals 8, b equals 0, and c equals negative 5. Again, if it's an empty space, we use 0 to symbolize that space. For this example, here's the graph of k of x. On Edpuzzle, please label a, b, and c for k of x equals negative 4x squared plus 6. Notice that there is a missing linear term. So what do a, b, and c tell us about the graph of the function? Well, it tells us at least 3 things. It tells us the direction of the graph, the width of the graph, as well as the y-intercept of the graph. Let's focus on the direction first. So if a is positive, the quadratic function opens up. Again, if our a value is positive, the graph opens up. So it would look something like this, where it almost looks like a U. It opens up. Now, if a is negative, the graph will open down. So again, if our a value is negative, the graph opens down. So it would look something like this. Notice here it's opening down. So let's look at this example. We have f of x equals 3x squared minus 4x minus 6. Notice our a value is 3, so it's a positive 3. Again, a equals positive 3. So I know that the graph of this function opens up because a is positive. Notice here our graph opens up. What about when g of x equals negative 2x squared plus 7x plus 1? We only focus on the a value, and we notice that a equals negative 2. It's a negative, so the graph of the function opens down because a is negative. And notice our graph of this function, it is opening down. On Edpuzzle, please fill in the blanks. Remember, if a is positive, the graph will open up. If a is negative, the graph will open down. Next, let's look at the width of the graphs. So the a value also tells you about the width of your quadratic graph. So a larger a value would mean that you have a narrower graph. Let's look at some quick examples. So if a equals 1, our quadratic function might look something like this. But if we have a larger a value, so a bigger number, maybe like a equals 7, then our graph would be much more narrow. I tried playing around with it on Desmos to give you a visual. So a larger a value means a narrower graph. This is the same for a negative a value. Just focusing on the number itself, notice that as the number increases, the graph becomes narrower. Let's compare these two functions. I have f of x equals 3x squared plus 4x plus 5. And I have g of x equals 2x squared plus 4x plus 5. Which graph is going to be more narrow? Let's focus on the a values of each function. For f of x, a equals 3. So again, a equals 3 for f of x. And for g of x, a equals 2. Again, a equals 2. Which one has a larger number? Which one is bigger? A equals 3. So f of x is narrower because it has a larger a value. For the width of the graph, we focus on how large A is. So let's take a look at the two graphs. Notice that f of x, the blue graph, is narrower than g of x, the green graph. For this next example, we're going to compare f of x equals negative 4x plus 3x plus 2 and g of x equals negative 8x squared plus 3x plus 2. Which one is going to be more narrow? Again, we focus on the a values. For f of x, a equals negative 4. Again, a equals negative 4. For g of x, a equals negative 8. Even if it's negative, we're just going to focus on the actual numbers themselves. So 4 and 8, since 8 is bigger, g of x is narrower. Again, because it has a larger a value. So g of x is narrower because it has a larger a value. So let's look at the graphs here. Notice that g of x, the green graph, is narrower than f of x, the blue graph. For this example, which function would have a narrower graph? Please focus on the a values. A quadratic function written in standard form also tells us about the y-intercept of the graph. The y-intercept is where the graph crosses the y-axis. So where does the graph cross the y-axis? That point is the y-intercept. So remember, on a coordinate plane, we have an x-axis and a y-axis. Let's say we have a quadratic function graphed. This point is the y-intercept, and this point is found by 0, c. So when we look at a quadratic function, the c value tells us the y-intercept. So the c value tells us where this graph will cross the y-axis. For our first example, we have f of x equals 6x squared minus 5x plus 7. To find the y-intercept, we focus on the c value. So here, our c value is positive 7. Again, c equals 7. So our y-intercept is 0, 7. Again, we can find the y-intercept by focusing on the c value. Notice here that the graph crosses the y-axis at the point 0, 7. Notice here we have g of x equals 4x squared plus x, and we want to find the y-intercept. But where is the c value? Notice it's empty here. Remember, whenever it's empty, there's a 0. So in this case, c equals 0. So our y-intercept is at 0, 0. Again, the y-intercept is simply 0, c. Here's the graph of the function. Notice it crosses the y-axis at the point 0, 0. On Edpuzzle, please find the y-intercept of the function h of x equals 4x squared minus 2x minus 8. Remember, the y-intercept has the form 0, c. So let me show you some examples of how you'll be answering questions on the Delta Math assignment. Your problems will look like this. Which equation best matches the graph shown below? And you have 4 options to choose from. Which equation best matches this graph? We'll find out by focusing on the characteristics of the graph. For example, notice that this graph is opening down. That means our A value is going to be a negative. Again, it's opening down, so A will be negative. I have 2 options down here where A is negative. The other 2 are incorrect because A is positive here. We also focus on the y-intercept. Here the y-intercept is 0, negative 5. That means C equals negative 5. So which option has C equals negative 5? This one. This option is incorrect because C is not equal to negative 5. This one is the correct answer because A is negative and C equals negative 5. Focus on the direction of the graph as well as the y-intercept to find the correct equation. Let's walk through one more example together. Notice here for this graph, it's opening up. Again, it's opening up, so A is going to be positive. So let's look for the choices where A is positive. Which ones have a positive A value? These 2. The other 2 are incorrect because A is negative. Next, let's look at the y-intercept. Notice here our y-intercept is 0, negative 7. So C would equal negative 7. Let's look at the C values here. We have negative 7 and negative 7.3. That one's incorrect. This one is correct. We found the equation where the A value and C value match the needed conditions. A is positive and C is negative 7. Today we learned that the standard form of a quadratic function is f of x equals ax squared plus bx plus c. If A is positive, the graph opens up. If A is negative, the graph opens down. The larger the A value, the narrower the graph. And the graph has a y-intercept at 0, c. Please make sure to submit your notes on Canvas and move on to the assignments.